So after looking at an example, I want to just briefly show why this extended linearity principle does always work. Why is it that once you get one particular solution, you can just add any and all homogeneous solutions, the general homogeneous solution, and the result will be a solution to the non-homogeneous case. And it's a pretty direct route to see why this is true. So we want to show that if you take a particular solution, yp, and you add your general solution to the homogeneous, which I'll call yh, we want to show that that will always work in the non-homogeneous differential equation. So when we're going to plug that in, we're just going to check it. We're going to plug this in for y here and for y here, and we'll see that both sides are the same. Now, we're doing this a little bit abstractly because we don't know what a of t and b of t are, and we don't know what y sub p and y sub h are exactly, right? But we're going to show that it doesn't matter and that it will always work anyway. Now, yp is already a particular solution to this differential equation. So we know that the derivative of yp dt equals a of t times yp plus b of t, right? We already know that yp on its own works when plugged in. So that's what that would look like. And we know yh works if you plugged it into the homogeneous version of it. So in other words, dyh dt is a of t yh, and that's it, without the b of t. So we have both of these to work with. All right, so if we plug this into here and here, get a left-hand side, get a right-hand side, we should see that they are equal. So let's see, on the left-hand side we will have dy dt. Okay, but that is the derivative of yp plus yh. We're plugging it in, right? We're plugging in yp plus yh for y. And we can just use the addition rule for derivatives. It just says, you take the derivative of each part separately. So that's the left-hand side. Okay. And on the right-hand side now, we have a of t times y plus b of t. Now let's plug in our y, which is yp plus yh. Okay, and I'll distribute the a of t. So a of t yp plus a of t yh, and then we still have the plus b of t. And the question is, does this equal this? Well, here's where we bring in what we know. We know that dyp dt equals a of t yp plus b of t. So this guy equals this plus this. And we know dyh dt equals a of t yh. So this guy equals that. So yeah, check, it equals. And that's why it works. So that is, in a sense, not in a sense, that is actually a proof that this extended linearity principle will work, always works. We saw it in an example, and now you sort of see it in its generality and why it's true.